sets, we want to do order of operations, so we're going to do what's in the parentheses first. Okay, so parentheses first. Okay, so I'm going to do A union and then B intersect C. So I'm going to look at B and C. They both have a 2 in them, they both have a 3 in them, and they both have a 6 in them. So my intersection of B and C is 2, 3, and 6. Okay. So now I'm going to unite A with the set 2, 3, and 6. So A is 1, 2, 3, 4, 5. So I've got 1, 2, 3, 4, and 5 from A. I had 2 and 3 already from B intersecting C, so I just need to add that 6. Operations for you. Okay, so you have parentheses, and then you have complements, which that's when you have the little accent mark, and then you have unions or intersections. Okay, for this example we have 2 sets of parentheses. So first I'm going to unite A and B, and then I'm going to unite A and C. So what I'm going to do is I'm going to say A union B. So I've got A and B. A is 1, 2, 3, 4, 5, and B is 1, 2, 3, 6, 8. So they both have 1, 2, 3. And then A has 4 and 5, and B has 6 and 8. Okay, so that was this first part. And then if I unite A and C, A again is 1, 2, 3, 4, 5, and C is 2, 3, 4, 6, and 7. So I've got 1, 2, and 3. That's from A, and then the 2 and 3 from C, on a 4. 5 from A, and 6 and 7 from C. Okay. So now I've done each of the parentheses. So if I want to, I'll call that just set 1, and I'll call this set 2, right? So set 1. So now if I want to intersect those, they have a 1 in common, a 2, 3, 4, 5, and 6. What they don't have in common is this 7 and 8. So my intersection is 1, 2, 3, 4, 5, 6. Here I have A intersect, and then the parentheses B union C prime. I have to find out what C prime is first before I can unite with it, right? So that's my first step. I'm going to have to find C prime inside the parentheses. So my universal set is 1 through 9. C prime is 2, 3, 4, 6, and 7. So if I go to my universal set and I cross out 2, 3, 4, 6, and 7, C prime is 1, 5, 8, and 9. That's what's left. So then if I unite that with B, B is 1, 2, 3, 6, and 8. So they both have a 1. I have 2 and 3, 5, 6. They both have an 8, and then a 9. So this is all of the elements in C prime and all the elements in B.
So wait, when a set is prime, it's just whatever numbers aren't in the universal set?
No, whatever numbers are left over in the universal set. Yeah, after you take those
I
out.
said it weird, but that's yeah.
Yeah. Whatever's left over.
Okay.
So that when you take C prime and you add C to it, you get U. Okay, so then that's the B union C prime, and now we need to intersect that with A. Okay, so this one is 1, 2, 3, 5, 6, 8, and 9, and then A is 1, 2, 3, 4, and 5. So if I look for the things that overlap, I have a 1, a 2, a 3, and a 5. Okay, so this set is going to be 1, 2, 3, and 5. Okay, so when you have 3 sets, A, B, and C, your Venn diagram looks like this. So you have 3 circles that overlap. Everything in this one circle here are in A. Everything in here is in B. Everything in here is in C. Okay. This region right here, this like football shape, that's everything that's in A and B overlapping. This football shape is where B and C overlap, and this football shape is where A and C overlap. And then this part right here in the very middle is the part that overlaps all 3. So this part would be A intersect B intersect C. So to find the sets, if we're going to find A, we're going to look at all of everything that's in the circle of A. So I have 11, 3, 12, 5, 7, and 6. And I'm not going to worry about order right now. Normally you go ahead and put them in numerical order, but at this point, more concerned that you get all of the elements than that you put them in order. Okay, so that's A, everything that was in this circle. A union B is everything that is in both circles. So I have 11, 3, 12, 5, 7, 6, and then 1, 2, 10, and 9. So that's everything in these 2 circles. B intersect C. That's this football right here where the circles of B and C overlap. So that's the set 5, 7, 9. The complement of C or C prime is everything that's not in this circle. So that's 11, 3, 12, 1, 2, and 10. Right? Because that's everything that's outside of that circle. And then A intersect B intersect C. That's just this middle part where all 3 circles overlap. So that's 5 and 7. Okay, so E and H, only 2 letters in all 3. Then we can look at where A and B overlap, and that gives us this whole football. I have an A, no A. B, no B. Or sorry, D, no D. E, but we already had the E here. G and G, so G goes there. There's the H, but we already had the H. And then there's an I and an L. So that's, G is the only thing left that overlaps A and B. Now I can take B and C. There's a B here, but no B here. The E we already have. There's no G. The H we already have. And there's no L. So that means there's nothing going to happen right here because nothing else is overlapping. So this area will be left blank. And then I'll do A and C. They both have an A. And then that's it because they already have the E and H right here. So now we have all the overlapping. So we look at A, and I'm going to cross out the letters I've already taken care of. So right, I have A, G, E, and H. So that leaves me with D and I. Oops. Not. Okay. I'll come to B and I'll cross out the letters I've already dealt with. And that leaves me with B and L. And if I come to C and I cross out everything, that leaves me with C. Okay. But I'm still not done because I have this universal set to deal with. So I'm going to go through the universal set and I'm going to cross out every letter that I've already used. And as you can see, I have a couple of letters left. And those are going to just hang out here. DeMorgans law. DeMorgan was a mathematician, I want to say late 1500s. And he actually discovered that if you take the intersection of A and B, and you take the complement of it, so in words, okay, so this is actually how he wrote it. He wrote the complement of the intersection of two sets is the union of the complements of those sets, which is a really fancy way to say this. Okay. He also discovered that, not the opposite exactly, but if you switch the union and intersections, it's still true.
So it's like a reciprocal kind of.
Kind of, yeah, exactly. Okay, so why is this useful? This is actually less work than this. If I'm finding an intersection of two sets and then taking the complement of it, that's 2 steps. Here I have to take the complement of A, the complement of B, and then unite them. That's 3 steps. So this is a nice, useful shortcut. If you're asked to find this, you can instead find this. It's less work. Okay, when we talk about these words that you'll see, like or, right here, serve free breakfast or both, or they'll throw an and in there or a but. and is an intersection. And you think about that, I mean, it makes sense. And. It's this and it's that, so it has to be both, right? So that's an intersection. Or is a union. And it can come from either or, so that gives you the whole range to choose from. Not is the complement. And then but. That's also an intersection, even though it doesn't really sound like it. But it is. Okay, so if I was looking just at this example right here, this little part in the middle, this 120, that's going to be an and or a but.
Huh? Oh, it's A and B.
It's an intersection, right? So it's both A and B. So it's and A
So
and B or A something but B. So that's going to be the and or but. The or is going to be everything that would be in both of these. And if I said not, if I was not A or not B, it's going to be everything out here, the 290. Okay, so we had done that campus survey earlier in the notes, and students are asked whether or not they'd be willing to donate blood, serve free breakfast, or both. Okay, A is the students willing to donate blood, so that's all of these people. B is the students willing to serve free breakfast. That's all of those people. And these 290 people down here are the ones that went, I'm not doing any of that. Okay. So, we're going to use this information to answer these questions. Okay, how many students are willing to donate blood? Well, the A is the people willing to donate blood, so you have 370 and 120. Because you've got those two regions in A. So that's 490 people are willing to donate blood. How many students are willing to serve a free breakfast to blood donors? You've got the 220 that are willing to serve the breakfast plus the 120 that are willing to do both. So that gives you 340 people. If you take how many students are willing to donate blood or serve breakfast?
yeah.
Oh, I did. Thank you. C. Thank you. How many students are willing to donate blood and? And is the intersection, so that's 120. Yeah. Because those are the people that are overlapping, right? Now we go to the or. Or is all of A and all of B. So I have to add the 370 and the 120 and the 220. So that gives me 710 students are willing to help out in some way, donating blood or serving breakfast or both. Yeah. Okay. How many students were willing to donate blood but not serve breakfast? Yeah, that's that moon over there on the B. Oh, sorry, not 200, 220. I meant to write 220.
Wait, I'm confused on that one.
Okay, so we come back over here. This is all of the people willing to serve or donate. Yes. Thank you. Here, let me erase that. Donate blood but not serve breakfast. That's A. Okay, so here's the people willing to donate blood but not serve breakfast. These 120 are willing to do both, so it's only these 370 over here. Okay, and here, serving breakfast but not donating wrong arrow. That's these people over here are willing to serve breakfast but they're not going to donate blood. So those are 220. And then the people that are not willing to do blood or breakfast, those are those 290 there at the bottom. They don't want to do any of it. And then the total number of students that are surveyed, that's every single student on this page. So that's 370 plus 120 plus 220 plus 290. So that's 1,000.
Oh, guess that.
Right? So what we're going to do is we're going to take the survey's description and define sets, and we're going to make a Venn diagram. We're going to use the survey results to determine the cardinality for each region. So that's what we did over here. We didn't list 370 different student names, right? We just said there were 370 students in this area. So that's what we're going to do here. We're going to list numbers of people in these areas, not the actual people themselves. Then we'll start with the intersection of the sets, and we'll work outward. And then we'll use the completed Venn diagram to answer the questions. Okay? So we have 2,000 randomly selected U.S. and Mexican adults are asked the following question. Do you agree or disagree that the primary cause for poverty is social injustice? Okay, so 1,600 people agree with the statement. 400 Americans are agreeing with the statement. All right, so we don't know, they're not telling us anything about the Mexican population. They're just telling us about the American population specifically here, or that 1,600 total people. So what we're going to do, bless you, is this are people being interviewed in the U.S. Okay. These are all the people that agree. So U.S. is Americans. A is for agree. Okay. We know 1,600 people agreed with the statement. So that's 1,600. 400 of those are Americans, so they come into this section over here. So 400 Americans are both American and agree. If there were 1,600 total people that agreed and 400 of them were Americans, how many people go over here? 1,200. So that right there tells me how many Mexicans agreed, right? Okay. Wait, I lied. It's not 1,200. I have to fix that. Sorry. Instead of being 1,200, it's 1,060 minus 400. So that's 660 that goes over here. And that's why I was like, no, that's not 1,200. That's too many. But, okay. No. Now here we have half of the adults surveyed are American. 2,000 are totally surveyed. Half of them are American, so that means 1,000 were American. 400 agreed. How many didn't? 600.
600.
Okay. And if these 660 that agreed are not American, they're Mexican, right? So if I take that 1,000 Mexicans that were surveyed and subtract the 660 that agreed, that leaves me 340 that did not.
So 340 didn't agree with it?
Mm-hmm. So how many Mexicans agreed with this statement?
1,060?
That's right here.
Oh.
Just the Mexicans. 660, and then 340 disagreed with the statement. All right. The following information was obtained. We have comedies, dramas, and science fiction. So comedy, drama, sci-fi. Okay. 6 people like comedies, dramas, and science fiction. So that's going to go right here in the middle. Because that's all 3, right? 13 people like comedies and dramas. So we have comedies and dramas. This football has to have 13 in it. So we get 7. Because 7 plus 6 is 13. Okay. 10 people like comedies and sci-fi. Well, here's 6, so if there's 10 total, there's 4 left. Because 10 minus 6 equals 4. 11 people like drama and sci-fi. So we have 11 minus 6. That gives me 5. 26 people like comedies. So that's this whole circle, right? So I have 26 minus, basically minus 17. So there's going to be 9 over here. 21 people like dramas. So that's 21 minus 18. So that's 3. 25 people like science fiction. So that's 21 minus, yeah, 25, thank you. 25 minus 15. So that's 10. Now, we need to see, there were 60 people contacted. So we need to figure out what number goes out here. So I'm going to take that 60 and I'm going to subtract every number that's in here. Sorry, not comma. What am I doing commas? And that equals 16. So 16 people that were surveyed do not like comedies, dramas, or sci-fi. How many people like comedy but not drama or science fiction? Well, that's going to be just this part right here. So 9. B is how many people like drama and science fiction but not comedy. Oops. Well, we have drama and we have sci-fi but not comedy, so it's this area right here. So that's 5. C, comma, dramas or science fiction but not comedies. Again, with the wrong. Okay, so drama or science fiction. That means all of these, but not comedies, so except for not this. So I have 5 plus 3 plus 10, so it's 18. D, we have exactly one movie style. Oh, I keep going the wrong way, sorry. So I have exactly one movie style are these outliers. So 9, 3, and 10. E, at least 2 movie styles. Sorry. That's these footballs. These people like at least 2 movie styles. So you have 7 plus 4 plus 6 plus 5. So that's 22. And then F, how many people don't like any of the movies? That was that 16 that was not in the circles at all. That's not what I meant to hit, sorry.